Good morning to one and all. I am Parthiban working as an assistant professor in the Department of ECE, Sri Muthukumaran Institute of Technology, Mangadu, Chennai. Now I am going to talk about the subject called satellite communication, which is coming under the regulation R 2021. The subject code is CEC 352. Now I am going to talk about the Unit 4, particularly about the TDMA and Aloha. TDMA is nothing but the time division multiple access technique. Unlike FDMA, where users are separated by frequency, the TDMA separates users in time. So every station uses the same carrier frequency but transmits during a unique time slot. The presentation also includes Aloha, a random access protocol that is derived from TDMA concept and widely used for bursty data communication. So TDMA is a digital multiple access technique in which there are several earth stations share the same transponder frequency by transmitting in different time slots. So the basic principle involves same frequency, same satellite transponder but with different time slot. The concept of TDMA, suppose four earth stations share a transponder, the time frame can be split in this way, that is station A, station B, station C, station D, like that it can be assigned. Why TDMA is called digital technology? Because it is a truly digital in nature. Before transmission, the voice signals are digitized, the video signals are digitized, the data already exists in the form of digital. So the information can be converted into bit stream or as data packets. Thus, TDMA naturally supports the digital communication. The evolution of TDMA has been developed for large earth stations, high-speed communication networks. The typical throughput range of TDMA lies in 60 megabits per hour or 100 megabits per hour or 250 megabits per hour. So modern TDMA systems uses advanced digital techniques that will have a reduced cost, higher reliability and more data rate. Because of its reduced bandwidth requirement, it is very popular because of its reduced uplink power also. So it is very popular. It has the incremental growth because it has easy scalability, cost effective upgradation, or these are the primary features that we can have for TDMA. So TDMA is unlike FDMA, it do not transmit continuously. They transmit only during the assigned time slot. It is called burst transmission we can see. A burst is a one which is for short duration, high speed transmission with accurately carrying the accumulated data. So typical TDMA signals are restricted to assigned time slots before it can be transmitted into burst. So TDMA signals are time frame in periodic and allows stations to transfer a continuous stream of information on average. So reference timing for start of frame is needed to synchronize the network and provide control and coordination. So this can be provided either as an initial burst by means of a reference earth station or on a continuous basis from a central lab. The earth station equipment takes one or more continuous stream of data that stores them in buffer memory and transfers to the output. So satellite in a burst or high compressed speed, that is what the need of our is. So TDMA at the receiving earth station, the burst from the earth stations are received in sequence and it has been selected for recovery if addressed for particular station. Then the spread back out time and output expansion buffer will come into picture. The individual time slot must be pre-assigned to the particular stations or provided as a reservation we can say. Then both actions coming under the master controlled by the station. For traffic, the requires consistent or constant timing. For example, if we are transmitting a voice and TV, the time slots repeat at the constant rate. So computer data and other forms of packetized information can use a dynamic assignments of bus in a scheme like a DAMA, or it's also called DAMA, that is demand assigned multiple access technique. There is an adaptation for data called Aloha that uses the burst transmission but eliminates the assignment function of master control. Aloha is a powerful technique, particularly for low-cost data networks that need a minimum response time. The throughput generally, which is nothing but the output when the nodes are heavily loaded, must be less than 20% if the bus comes from the station that are completely uncoordinated, because there is a potential for time overlap, or we can say collision, that may occur. The TDMA Aloha, the most common implementation, employs a hub station that receives all these bursts and provides a positive acknowledgement to the sender if the particular burst is very good. If the sending station does not receive the acknowledgement within the time set window, then the packet is again resent after a randomly selecting period is added to prevent another collision. This combined process of window plus added random wait introduces time delay, but only in the case of collision. The throughput greater than 20% brings a higher percentage of collisions, resulting in a retransmission that will introduce the delay that is unacceptable to the acceptance. So general advantage of TDMA lies in its efficient bandwidth usage, no intermodulation effects. Unlike in FDMA, IMD is completely eliminated. We can say a higher throughput, that is up to 90%, can be done. The flexible capacity allocated slots can be reassigned. Particularly, it is very suitable for digital system since it works naturally with digital communication system. The only complexity, or we can say limitation, of TDMA lies in its complex synchronization one. It needs a precise timing is needed. The another limitation, we can say, it needs buffers. So the memory required for both ends, that is important aspect that we have to take into account. Then there must be a delay will be there. The user must wait for the assigned time slots. Then the complex network control, that is also another one limitation that we have to take into account. And since it requires a centralized management system. So for this only we have introduced the slow Aloha, which is an adaptation of TDMA. Aloha is a random access technique where the stations can transmit wherever they have the data without waiting for the assigned slots. The working principle of Aloha, that is in TDMA, in Aloha will differ. In TDMA, it transmits collisions. The collisions can occur when the two transmitted stations simultaneously. If the transmissions overlap, both packets gets destroyed. So the uncoordinated Aloha can have the maximum throughput of less than 20% only because of the frequent collisions. These are the things that we have taken into account before reading into the Aloha system. So with that, I am winding up my lecture. Thanking you one and all for hearing my lecture. Thank you.